Good morning, and as always, slow is smooth, and smooth is fast. So what I want to talk about today is accuracy and precision. So this idea of accuracy is if you achieve a single goal, what you're looking for, you can consider that you accurately hit your goal. While if you hit the same result repeatedly, you can consider that precise. An additional note that I want you to add is that in science, we care more about precision or being precise than necessarily being accurate. If we know that something is precise and we can get the same result over and over again, we consider that to be better data than if we see that we get one result that we want once. So let's look at this idea of accuracy and precision. So if we look at student arrival times, 7:40, 7:30, 7:42, 7:35. If we look at student 2, 8:29, 8:28, 8:30, 8:29, 7:35. For student 3, 7:35, 7:36, 7:35. While student 1 arrived on time, they didn't arrive consistently. So we can say a couple of these are accurate, but they're not very precise. Student 2 is very precise in when they arrive, but they're not very accurate. They're not hitting the time that they're supposed to be here. While student number 3 is accurate and precise. I want you to add those notes on the side here. Student number 1 has some accuracy, student number 2 is very precise, and student number 3 is accurate and precise. You can have both. When trying to determine accuracy, we have an equation. We're going to follow the equation here. We're going to take our experimental data. We're going to subtract our accepted data and divide by our accepted data. We're going to multiply that by 100 to get percent error. This is an equation that gets used often, especially from my background in cosmetics. I used to work at the cosmetic company Avon, so we use this equation a lot. For example, we used it when filling lotion, soaps, pretty much anything at Avon. They used this equation to determine how close they were getting to the amount that they wanted. So if a lotion should have 500 grams, they've decided that 500 grams is the right amount of lotion to go into a bottle. They bring up a bottle and they say, okay, we actually filled the bottle 980 grams. It's supposed to be 500 grams. We're going to take the absolute value of that number, which means we're going to make it positive. And then we divide by the accepted, how much it's supposed to be. We multiply that by 100 to find our answer. So I would like you guys to sit down and figure out what is the percent error when you fill a 498 bottle that should have been 500. Keep in mind, there's always going to be a tolerance on real-life items. They're not always going to be filled to that number. They might be a little bit more. They might be a little less. They just need to be within a certain amount. And that's what percent error helps us figure out if they're within the amount that they're supposed to be or not.